Stop it. Can we stop for food?
No, hay comida en la casa.
"2025 was just the beginning.
Yeah, good boy. Mr. Smorgas? Mr. Smorgies? Mr. Smorgas? This is on a short cord. Oh, we're not on autofocus. Smorgas! Smorgies! I can't. Where? Hello? Smorgas! Hi, Bobo! Okay, let's get this camera mounted in a different way. How do you like my nuts, chat? You like this nut? And you have the worst audio quality right now. You are literally running off of the camera mic. So get fucked. You like these nuts? How do these nuts look? Let's see if we can get it to focus in there. If not, manual focus. Oh yeah. That's a good looking nut. That's a good looking nut, chat. Let me pull up Twitch chat. Holy shit, I don't have Twitch installed. Oh, I don't have Twitch installed. Oh god. Twitch. Just hold on, chat. Don't chat right now. I can't read it. Just give me a second. Log in. My username is Gamozo. Password Hunter2. Okay. 2-factor 133767. Turn on notifications? Sure. Fuck it. Okay, now we're on Twitch. Gonna unmute my mic. Okay, can I do just a full screen chat? Can I do just a full screen chat? Nice threads, right? You're telling me those aren't beautiful threads? Oh, they turned out great. Okay, so, right now the camera is currently not mounted in the right setup. So, I gotta go get a flathead screwdriver. I'll be right there, Smorgas. Mr. Smorgas? Mr. Smorgas? Smorgumbus. Smoogle. Okay. There we go. We got a big flathead. Okay. Am I going to be able to do this without disconnecting the stream? I don't know. Well, the stream won't go down because the camera is streaming to the computer. Oh, okay. Got that. Now we got to put the camera in the cage. How are we going to do that? Twitch chat. Is this lens gonna fit in here? Oh, don't make me take the lens off. Oh, Twitch chat. Oh, Twitch chat. Oh. It's happening. It's happening. Okay. Oh, shit. I might have to replug the Hidimi. Okay, we're sliding this in. We're not going to drop anything, chat. Okay? Well, I got to unplug the Hidimi, okay? Well, how long do I have to do that for? Let's see. Oh, and I got to unplug the camera. All right, I'll be right back. Fucking easy. See? Such whiners over there, chat. Whoa! Where'd my streamer go? Where'd my streamer? My streamer went away. Where'd my streamer? Where'd my streamer go? Okay. Okay, we can put our screwdriver away. We can put this screwdriver away. Okay. Does this mean I can go wireless? I think so. I think everything is connected to everything else. Okay, we'll coil the coil around this. There we go. Kind of cleans things up, maybe a little bit. A little sketch. Is this everything? Is this everything? Everything is connected right now? Is that true? Is that true? Now I gotta pee. I'll be right back. Okay. Oh, I'm coming. I'm coming. Is that a good boy? Is it the best boy? Is it the best boy in the whole wide world? Is it the best boy? Is it the best boy? Is it the best boy? Who's a good boy? Who's a good boy? Is S'mores a good boy? Is that S'mores? Is that S'mores? Is that S'mores? I see a S'mores. I see a very good Mr. S'mores over there. That's one of the best looking S'mores I've ever seen. Look how good of a boy you are. Is your tail? Is your tail tailing? Yeah, who's a good boy? Who's a good boy? You're a good boy? You're a good boy? Yeah, you're a good boy. Yeah, okay, I'll come over there. No, okay, I'll come over there and give you some pets. Let me see if autofocus works. We're gonna do autofocus. Hey, don't lick the lens, S'mores. No licking the lens. We're gonna do autofocus for near. Hopefully this. Oh, I don't have it on continuous autofocus. I also don't have you in 60 FPS. Okay, now you're in 60. Okay. And then, how do I get the focus mode to do the thing? Is it this? Is it this? No, it says it's on continuous, but why do I have to hit the button at all fucking times? Oh, and we'll turn on optical steady shot. Wait. Half a meter to 0.28 meters. Okay. Well, who's a good boy? Who's a good boy? Okay. Just relax, chat. Just relax. I'm trying to figure this out. This isn't easy, okay? If this was easy, everyone would be a Twitch streamer. But it's actually very hard. We'll do a zone focus. Well, hi, Bubble. Well, hi, Mr. Smumbo. Who's your best boy? Who's your best boy in the whole world? Who's your best boy? Is it you? Is it you? Yeah. Oh, was that a big yawn? Was that a big yawn? You working on a bone? You working on a bone? You think I'm an idiot right now? Yeah, okay. Okay, well, my hand's getting sore. Let me go get the tripod. Okay? You want me to zoom in on your nose again? Well, you gotta stay in one spot. Oh, good boy. That's a nice nose. That's a nice nose point. But you're a good boy. Okay. Okay, Bubbles. Who's the best boy? Mr. S'mores is the best boy. Okay. Alright, I gotta get the, I think I have the adapter on here, so I just need to grab the tripod. What's this lens? It's macro lens. Let me get the tripod. This tripod is so fucking heavy, chat. Okay, let's make sure the tripod works. Should. I don't think I did anything sketch to it. Okay. And this goes which way? Which way is forwards? This way? Okay, and then we'll put the camera in, and, we're locked in. Chat, we are locked in. Okay, let me release that, and we can go into s'mores mode. Okay, who's your best boy? Who's your best boy? Who's your best boy? Who's your best boy? Yeah, look at that. That's a good boy. That's a good boy. That's one of the best boys in the whole wide world. A natural s'mores in his habitat, eating some bone. One of the best boys in the whole wide world. He's known for eating bone. He's very cozy on the couch. He's looking for some cuddles and for some snuggles. But that is what a wild s'mores is like. So, let's go and see if we can approach the wild s'mores, or if the s'mores is going to be vicious. Let's see. Chat, I'm gonna sneak in. I'm gonna sneak in, okay? I don't know if I lose chat when I put my phone in my pocket. Okay, so it looks like we got a feisty s'mores here. It looks like we have a very feisty s'mores. He is going extra hard on his bone right now. I need to be very cautious. A s'mores in this position could snap at any time. He's licking my phone. We took a boy. Okay, I can confirm. As I've gotten up close, I can confirm he is a good boy. He's a good boy. Are you a good boy? Why can't I see my screen? Why can't I see my screen? Is my screen working, S'mores? Okay, it is. It is. Good. Who's your best boy? Who's your best boy? Who's your best boy? Have you been chewing on a bone? Have you been chewing on a bone? Oh, yeah. Do you like your ear scratches? Does that feel good? You like your ear scratches? Yeah. Who's a good boy? Who's a good boy? Who's a good boy? Mwah. See, you're not a bear. You're a very, very nice dog. Everyone says that you're a bear, but you're not a bear. You can't be a bear. If you were a bear, you'd be eating me right now. Like you were eating that bone. So you're not a bear. Yeah. 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 Oh. Yeah. Who's a fierce big s'mores? Who's your good s'mores? Who's your best little s'mores? Who's your best little s'mores? Who's your best one? Who's your best one? Oh, are you attacking? Were you going for an attack? Is it still wet? You're gonna hop off the couch? You're just gonna jump on it? Oh, okay. Okay, S'mores. Alright. Who's your good boy? Who's your good boy? Yeah. Who's your best boy in the whole world? Hi, Bobo. Hi. Yeah, your bone fell. I'm being attacked. Who's your good boy? And you a little wet? Were you outside? Oh, now you're hopping off? What a good boy. What a good boy. So how's everyone doing today, chat? How's the camera looking? Is it working? Is it working? Play dead? Yeah. Hi, S'mores. Hi. Who's your good boy? Yeah. So, what? He's a good boy. Yeah. Is S'mores a good boy? Yeah. Okay. So, chat, I got the camera up and working. Turns out this whole time it was a firewall issue. A firewall issue that somehow isn't a problem on Windows but is on Linux, which is kind of strange. I don't know why that would be the case, but I fixed it. Hi, Trample. Hi, Mr. Trample. Oh, who's your good boy? Yeah. So we're gonna go out into the garage in a minute here, and we're gonna machine some parts after S'mores is done mauling me. Oh, he's getting a pillow. Oh, ah! So yeah, what have I missed? What's everyone been up to? It's a fun day to stream. Hi. Who's your good bubbo? Yeah. Hi. Everyone should get a dog. I highly recommend having a dog. This guy is just so much fun. Oh, you gonna get your squeaky toy? Yeah, you bringing your corn? You got your corn? You want to show off your corn, S'mores? Come here. Oh, yeah. You're a little off camera, S'mores. We gotta get you in frame. Let's get you in frame. Oh, hi! Yeah, that's S'mores. Yeah. some aluminum, I have some new clamps that I want to try out that I got, and I wasn't able to use them because the way they work just slid the T-nuts around. They're meant for like a rigid fixture plate. Because they put a lateral force on the part to like clamp it onto the table. And I wasn't able to use them because obviously T-nuts aren't rigid, so I just made some T-nuts that have holes for set screws, in theory, and hopefully I actually have enough set screws. I think I do. And we're going to put these in my Bridgeport table, and then we're going to put 2 set screws in the outside 2 M6 holes. And we're going to use that to basically make this nut press up into the bottom of the T-slot. And hopefully that will hold it in position so that we can use the center one to push laterally on a part. So that is kind of the theory. Now, if I can clamp the part from the other way where it's pushing against the T-slot, then it's like not really a problem. But in my case, just the way I had it positioned, I need these. So I made 4 of these little T-nuts. We got 4 of them. They're beautiful. Some of the first parts that I've ever used on with a tapping head. And I'm really happy with how those threads turned out. I mean, those threads are just beautiful. I don't know what this material is. Probably just a mild steel. These are just blank T-nuts I got off McMaster-Carr. But it's very hard to get these in focus when I'm not looking at it. Hi, S'mores. Yeah, you having fun? So, the plan is to try these out, because they turned out really good. We're going to hop out into the garage. Yeah! And we're going to try them out. And hopefully this lens is okay. This is my macro lens. It actually looks really good. I don't know if the 4K is killing Twitch or not. So, hopefully it's coming through fine. I'm also doing 4K 60. I could do like 4K 30. But my view is for machining. A lot of times I'm showing you up close to a part that hopefully is pretty low bit rate. Or not necessarily low bit rate, but it's not very moving. And thus I'm hoping that the 4K will just be better. 4K 30 would probably be best. But video quality is excellent. Good. Yeah, I hope you're getting that like bokeh that I'm getting on S'mores. Looking at them through the viewfinder is just incredible here. It's so cute. It's so cute. Look at you. Look at you, Bobo. Yeah, who's your best boy? Mr. Beef Tube. Mr. Beef Tube. Yeah, who's the Beef Tube? Who's the Beef Tube? Hi. Hi. Whoa. I'm gonna eat you, S'mores. I'm gonna eat you. Good boy. Good boy. Hey, give me a kiss. Can you give me a kiss? Good boy. Good boy. You're the best boy in the whole world, S'mores. Okay, I'm gonna turn off your light. Okay? You okay with that? You want a treat? You want a treat for being cute? Okay, let me get you a treat. What a good boy. What a good boy. You worked hard for that treat. I'm coming. I'm coming. Don't you worry. Don't you worry, Bubbo. I'm trying to be cinematic here. Yeah, good. Yeah, good. Yeah. Oh, yeah, good. Yeah, who's your best boy? Yeah. Yeah, who's your good boy? Oh, you're a good boy. Okay. Yeah, he does get treats for being cute. that is one thing that I will kind of always give him treats for. So, a lot of dogs can't do that, right? So that's kind of a skillful thing that he can do. Okay, let's get some water. Today we're having a strawberry peach LaCroix is going to be our beverage today. And, anyone see the bottom of the screen flicker? Oh, there better not be issues. There better not be camera problems, chat. I'm coming, Mr. Smumbo. He's the best little boy. He's made of beef. He's got floppy ears. He's looking at me. Who's the bestest little boy in the whole world? Who's the best? The bestest boy. Mr. Smudge is the best. Yeah, I'm putting on my overalls. Yeah, I'm gonna go into the garage. Yeah, yeah. You being a beef boy? Okay. There's an encoding issue. What do you mean? How can there be an encoding issue? Yeah. Whew. Ha. Whew. But I'm not gonna fix it. You guys just have to deal with it. Sorry. Get fucked. Oh. Okay. 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 Put this on. Put this on. Button this up high, Bobo. Yeah. Now, who's the best little boy? Oh, you are. You're a good boy. Yo. Who's a good boy? Who's a good boy? Yo. Hi. Okay. Okay, Smudge. Pop is gonna go into the garage for a bit. Is that okay? Yeah, I know. But when I come back in, we're gonna party, S'mores. We're gonna party, we're gonna snuggle. I'm gonna give you treats. You know what's gonna happen when I come back in. You know. Okay, I gotta do 2 trips to the garage. 1 to bring out these parts. I'll be right back, chat. Stay there. Be a good chat. S'mores, no licking the lens. I feel like I lose chat every time I put my phone down. That's so annoying. Okay, S'mores. Yeah. We're gonna go into the garage. Who's a good boy? S'mores is a good boy. Yo, who's a good boy? Who's a good boy? Okay, we gotta lock this. And we'll pull the legs up. And then we're gonna go for a little adventure. Okay, S'mores. Here we go. Here we go. Pop's going into the garage. You be a good boy. You don't eat anything. Don't eat any HDMI cables. You can have USB cables. The HDMI cables are too fatty. Okay. Oh, deploy! Okay. Is that tripod deployed? I think so. I think so, chat. Okay. Whew. Okay. So, this is a macro lens. I've never used it out in the garage. I think it's probably not going to work unless I have it right up and stuff. We'll see. But I was hoping that maybe it will work out okay. Because most of the shots that I want to get in the garage are going to be macro shots. So, let's see. How do I switch my focus mode again here? This. We're going to go small spot focus so I can focus hopefully like right on the quill there. Perfect. Okay, that's really cool. I actually think I'm going to like this macro lens. So, I'm going to put my nuts down. Actually, we're going to clean off that table. So, right now I have a chamfering tool in here. We'll pull that out, and then we're going to figure out where we want the table height, get the camera set up, kind of go through that process. Where's my WD? There it is. So we'll get the table cleared off. The last thing I was machining on this was those T-nuts, but I tried to keep it fairly clean. I've been trying to kind of clean up the shop before I go in for the night, which has been actually pretty rewarding. It feels really nice to come out here and the first thing is everything's pretty clean. So everything will kind of get a little oil on it overnight just from wherever I oiled dripping around. But this is pretty good. So we'll just give that a wipe down. Make it nice and clean. I've been using WD as my cleaner recently, and I've actually been kind of liking it. I'm a big fan of Goo Gone. I've been using Goo Gone, which is D-limonal. It's like orange citrus sort of thing. Works well for getting stickers off. I don't know if there's a name for it in Europe or something. I imagine you have a similar product because it's just kind of an important thing to have. IMO. I think the camera was tilting down a bit there. Sorry, chat. So I'll bring you in here and we'll take a look at the T-nuts. I also need to plug the camera in. Let's do that before I forget. And is this gonna reach? No, I need an extendo cord. Okay. There's one. We'll get an extension cord. And we'll be ready to party. Hell yeah. But yeah, I forget how long this camera lasts on battery. I think it's like a little over an hour or something, which is pretty damn good. But I don't want to test it. So we'll try and keep it plugged in. Okay, that's running. That's plugged in. And we're going to go into the battery pack charger, and we should be good. Okay. Okay, chat. Okay. Goo Gone is great for sticker crud. I agree, yeah. Goo Gone is, works absolute wonders. So, move this heater. It's actually been kind of warm here. Normally it'd be pretty chilly by now this time of year, but it hasn't been too bad. Do I have my broom? No, I think my broom is somewhere else. Okay. No broom. Alright, so, where am I going to be machining today? Probably up high here. So, I want to machine these pieces of aluminum. I just want to machine them flat. I can actually turn the monitor around so I can see if I'm in focus here. Pog. Okay. So these aluminum bars, they're, I've got 2 of them. I'm going to be turning them into a shit ton of mounts for a grinding table that I'm building so I can surface grind my milling machine. Or, not my milling machine, my lathe. So, my lathe, I've been trying to, like, scrape at it and improve it, but I haven't really been having fantastic progress on that, mainly because it's a hardened surface. The V's are really awkward. So, I decided probably about a month ago that I'm actually just going to grind the table, and I'm going to do it myself. The way I'm going to do that is I'm going to build a linear, like, carriage system underneath my big table, which is right behind you, and I can actually show you. That's kind of weird. I'm not used to being able to just show things. So, I have this big table here, and now the monitor's facing the wrong way. I really want, like, a double-sided one of these. So, I have this big steel table, right? And it's a 3/4 inch thick steel table all the way down. And so what I've decided to do is I'm going to build this, like, linear carriage system underneath this so I can put my lathe, which is over here, so I can take the lathe, put it underneath the table, then level the lathe on precision jacks, and then calibrate the rails that will be underneath this table, build something to hold a motor and a grinding wheel, and then grind the lathe right under a table, which I think will actually work, but I'm not 100% sure. So, basically I'm kind of starting that project right now. Let me see, I can actually bring up the CAD quick. I can't show you this in a convenient way, unfortunately. Let's see. So I'll get you in here in a second. It's this, I think. Yeah, okay. So the whole setup is this. Yeah, okay. Okay. Let me get you in here, chat. Press 1 if you're ready to get in here, chat. Oh. I have no idea where I need to put the camera. I need to raise it up. I'm going to need to raise it up to machine as well, so might as well get it over with. Here we go. Oh. Okay. 2 legs. 3rd leg. Okay. Everything's stable. Everything's good. Okay. Sorry. Alright, so basically this is the table that I've designed for this grinding project. And so you can see the whatever is in pink, blue, purple, orange, yellow, whatever. So effectively, I've modeled in the table here, which is the table that we're at, this steel table. And basically my plan here is to make, I have 2 long rails. These are 1.5 inch linear rail. So I've got 2 long ones for the x-axis, which I think I've designed this to like a 62 inch travel, whatever that is in meters, probably almost about 2 meters? 62 inches divided by 25.4, 2.4 meters, something like that. So that will be the travel distance, and then I have this Y carriage where I'll be able to move the motor, and then I have this table here where the motor will sit. I haven't designed out how I want to do the motor yet, but basically these rails extend like the full table. I've done rigidity simulations and all sorts of things, and I think this will be totally fine, especially with grinding, because grinding is interesting that you can keep making passes until you spark out. So it's okay if the grinding wheel has forces pushing up and deflecting the rails away from the part being ground, because the next time you come by, the wheel will be slightly lower and the cut will be lighter because it's just a lighter and lighter and lighter cut. So grinding, in my opinion, kind of converges to like no grinding forces, right? So I've designed this to basically have very, very minimal deflection, like 2 to 5 micron deflection under its own weight and what I think a motor will weigh, which I've kind of spec'd out one motor. I'm going to probably do a 2 horsepower motor and then put a VFD on this, which I think will actually be really cool because I think my plan is to kind of mount the VFD to the table, and then I'll effectively have like a 3-phase outlet that I can use. So if I want to use the grinder, I'll just plug in the grinder to that. But I'll have like a 3-phase controllable outlet like right on the table for kind of one-off things. It also will allow me to buy like a pedestal grinder, even a small lathe or something, and be able to kind of plug it in on the fly and not have a permanent setup for it. So effectively everything in here is aluminum except for the rails. The rails are a hardened linear rail, which are precision ground and everything. And really the part of this project that's kind of the whole experiment that I'm excited about is that the rails are going to be mounted on these like 1 by 3 by 1 inch, so like 75 by 25 by 25 aluminum mounts, which will be spaced kind of all down the carriageways. And I'm going to be able to put my precision level right where the grinding wheel is. So like when the motor's mounted up and everything, I'm going to mount the level right next to the grinding wheel, like on the same platform that the grinding wheel is mounted to. And that level reads to 1 micron per meter, actually a little less when you go into the software, which I do believe there is signal there, at least relative, not necessarily absolute readings. But effectively all of these mounting points means I can have like probably up to like 150, 200 micron errors, so like 0.2 of a millimeter error on these parts and tolerances and all sorts of things, because I can just shim each of those individually. So effectively I'll put the level right on the carriage, like the bottom carriage, and I'll do sweeps of this in all sorts of positions, and I'll effectively build a model of this. And if any of the rails is higher or lower than other parts, I would very obviously see that twist in my level, and then I can go in and basically randomly shim and unshim things until I get a reading that's basically 0 the whole way around, which effectively tells me that the whole system is perfectly flat, like tracing a flat plane in space, even though the system itself isn't perfectly flat. So effectively the goal is to have this like very, very moddable setup where everything can kind of be shimmed. This obviously won't hold tolerance very long, but for the lathe, for example, my plan will be to literally put the level on it, calibrate it, which will probably take like 15 minutes. I'll write some software where I just use a controller and I just like hit a button every time I want to take a data point, kind of sweep a grid with that grinding table, and then make modifications. Probably will take an hour or two to like tweak it, get it into whatever my tolerances are, probably like 2 to 5 micron. And then I just have to grind it then. So temperature changes, environmental changes, shifts of local gravity, shit like that won't really matter for this, because the table will be basically calibrated immediately before the cuts. In fact, I might do roughing passes, since I don't know exactly how much material I'm going to end up removing from the lathe. So I can do roughing cuts while it's not perfectly precise, and then do one final calibration, make sure it's bang on for like extremely light, no force cuts, right? So effectively, that's kind of the design. I don't see why it wouldn't work. Everything here is decently overbuilt in my eyes, so I'm hoping it will work. I think the only thing here that I'm a little concerned about is the way that these aluminum carriages ride on the rails. So to clear these mounts, right? These mounts they have a 60-degree arc on them. So basically subtract off 60 degrees from the circle, and that's what I have to work with for bearing on that mount. And effectively, I'm going to go 5 degrees less than the full circle. So I'm going to have 60 degrees on the mount, and then I'm going to have 295 degrees, I think. I might have made some small design changes for other clearances, I'm not 100% sure. But effectively, these mounts are going to, or the aluminum mounts are then going to go into a bronze bushing that I'm going to bore and ream, or maybe just bore, or bore and lap, I'm not 100% sure. But that needs to be an extremely tight fit to those rails. And I think with the forces I'm going to be working with here, especially on these 1.5 inch diameter rails, I think I'll be totally fine hanging 50 pounds off of it, which will basically be the whole weight of the motor, the carriage, the wheel, sort of thing. So I'm not too worried about it, especially since any sag that comes from it, I can compensate for during calibration. Really, the only issue that I can't do with calibration is dynamic forces, right? So things that change while it's under load or under the movements. But the plan would be to set up a little motor that like moves the wheel down the way, and I use that same motor with the same settings when I do calibration, and thus I'm literally calibrating what I will be doing for the cut. So the dynamic forces there is really just the contact with the wheel, which should, once you do the first couple cuts, should converge to basically zero, and thus I would expect I'd be cutting the original kind of calibrated geometry. But I'm not sure. We'll see. It's kind of an interesting design. It's pretty cheap. It's not too expensive. The linear rails were the most expensive part. I already have them. I guess tooling has been a little expensive because I've made the two rails for the Y-axis, which I haven't brought out here. I've actually been kind of trying to keep them inside and clean so they don't have any issues. But I've already drilled and counterbored those, which is very difficult because those are C60 Rockwell hardened, case hardened linear shaft. They are very, very, very hard, and I broke 1 or 2 carbide bits drilling them. I'm hoping that now that I have better readouts of kind of my speeds on my milling machine, that I'll be able to do that a lot more precisely, but I still might break some bits. Mainly because I'm drilling, I think those are M8 bolts, and I was drilling 5mm and then following that with the 8mm drill. And the problem is 5mm going through 1.5 inch, so whatever that is, like 37 millimeter thick rod. That's a very deep hole, especially when you're working with a really hardened material. So that's just pretty tricky holes to drill. I'm actually pretty happy that I got all of those holes done with just one pair of drills. I technically broke the drill on the very first hole, so kind of before I had a feel for it. But now I've forgotten, so I'm hoping that the next rails, because I have a couple more holes, I probably have twice as many holes for the large rails. I'm hoping I don't break any bits, because those bits are like $60 a piece. But yeah, that's basically the plan. I haven't started this project. I've done this modeling. I think this design I've kind of been done with for a month or two. I got all of the equipment probably about a month ago, and then I was drilling those holes, had some issues with that. So that sparked me to kind of do that FPGA DRO readout project, which tells me the speed that my milling machine is traveling at, which is really cool. So effectively, I want to start making the mounts. So those long aluminum blocks are what the mounts are going to be made from. I already have them cut to size. They're maybe a little long because I'm like completely maxing out the X travel on my milling machine, but they're not precision parts, right? But I like to do everything as if it's a precision part because it's just fun, right? It's fun to see if you can really hit tight tolerances, try new ways of clamping things, try new ways of cutting things, try new feeds and speeds. So that's what I'm doing here. So the main things are trying to get a really, really clean surface finish on aluminum, which I've always struggled with because aluminum's very soft. So if you get like any dirt or debris on the aluminum, you can put pretty nasty scratches in it, which just looks like shit. So what I want to do is really try and do the best job I've ever done milling aluminum, and I actually had really, really good cuts on these bars already. And then I needed to switch to use a side clamp to do some of the final passes because I had my clamps in one spot. And obviously repositioning clamps, like every time I think I can get away with it, but stuff always moves, shifts around, and I came in for other cuts. They just weren't perfect. So basically, I want to try and figure out if I can use these new clamps that I got. So I got some of these like Mighty Bite clamps that are basically these hexes. I need to look at the monitor so I can see what I'm talking about. So these Mighty Bite, you can see it's an offset. Thinking backwards here. You can see it's an offset screw, and that is intentional. It's actually like really cool to look at here, right? You have this offset head on the screw, and that basically means that this hex nut provides a camming action when you rotate it. So assuming that you have a rigid fixture plate where you can tap this into a rigid hole, like making an aluminum cheese plate or something, this gives you a non-zero amount of lateral clamping kind of travel distance. You get like maybe a couple millimeters up to like 5 to 10 millimeters for some of the larger versions of these. So you really don't get much travel out of it, but you can get 2,000 pounds of force out of like these big ones for lateral clamping force. And effectively, I want to use these on my Bridgeport in my T-slots so I can reposition them really easily. But to do that, I need to make the T-slots rigid or clamp from the other way on the table. So I'm going to take you over there. We'll kind of talk about this. I tried using these the other day. Obviously, it wasn't successful because with the T-slot, the lateral forces of this just pushes the T-nut down the way. Unless you got very lucky and this started to clamp down at the same time it starts pushing your part, which is just RNG. Like, you could, in theory, probably shim it to get it so they line up. But yeah, you fucking can't. So, I've made these new T-nuts that I was showing you inside. And I'm going to try and drape this charger better on here because it's really heavy and pulls on that plug. Okay, so I've made these new T-nuts over here, which go in the T-slots in the milling machine, and basically the goal of these T-nuts is they have holes in them on the outside. So a normal T-nut, I guess, I don't know how many of you are machining people. I imagine everyone here is a hacker programmer. So this is a T-nut. This goes into a T-slot, and effectively you're able to put all sorts of different clamps, bolts, whatever, just into this to kind of hold whatever you're machining, right? So I can just slam a bolt in here. So this is the normal size T-nut for this Bridgeport milling machine. This is a half-inch nut, or half-inch bolt, so like 12-millimeter bolt into this T-nut. And this goes into the T-slots on the table. And TLDR, you just can reposition these wherever you want them, and now I have a bolt hole here, which is really nice without having to actually put a hole permanently in the table. Now, the problem with those clamps that I got is, since they generate a lateral force, if I'm trying to clamp something that is parallel, or however you want to say it, the force is parallel to the slot, obviously that lateral force is just going to push these out of the T-slot, and that's what was happening. I was kind of hoping that there'd be like maybe enough give in the aluminum walls or a little bit in this brass and like kind of make it work, but unfortunately you're not going to get that at the right time. So effectively the lateral force is just going to end up pushing this out of place, even though it can kind of like cam and lock itself in there. I want to actually have a more rigid connection, and thus I made the T-nuts with the set screws on the side. So, I'm not going to be using my largest, I'm not going to be using these largest Mighty Bites that I got. I'm actually going to have to go to size down, because these are not 1 inch. These are, they're kind of weird. I put, it's a 3/8 inch hole down the center, threaded 3/8, and I have Mighty Bites for those. They're the one size down from these big ones. I think you can get like 1,000 pounds of force out of them. And then on the side, I have two M6s. Yeah, so I mixed Imperial and Metric. Fuck you. It's my own shop. I can do whatever I want. Okay. So, actually, let me pull up chat on my computer so I don't lose it. I forgot that I can just do that. So, let me pull up my own chat. I don't think I'm logged in. I am logged in. Nice. Okay. Nice. And that gives me another camera view in case things were to go to absolute shit. But this monitor is so fucking ass and washed out. Okay, yeah, let me check up on chat. Sorry, I haven't really been reading. First time chatting in this channel. Can someone tell me what's happening? Yeah, okay, I went through kind of the grinding table. That was a few minutes ago. You're the guy that was building a memory allocator in Rust? Yeah. Did you stop by for that stream, and then you came back for this one? You're like, I don't remember subbing to this. The fuck is this? Or not subbing, but following. Don't sub. I don't stream enough. Don't fucking sub. Okay. So, first of all, I just want to make sure my new nuts work with the 3/8 inch. God, I would fucking hope so. But I haven't tried them yet, so let me just make sure before we get set up. But I'm going to need to use 8 set screws for these 4 different nuts. And unfortunately, I don't have that many set screws. So, I really need to order more set screws, but I don't really know what set screw sizes I want. So, I mainly stock metric stuff. I try to do most of my machining in metric. In the US, that can be tricky at times. Supply just is limited, or you don't get as much say in what you want. But I stock a bunch of like M1.6 through looks like M8 or M10 bolts. But right now I only have button head and I forget what they're called. The ones where you need the countersink to put them in. Okay. So, let me grab these nuts. I think these are the ones. So, the theory is that these will hopefully go in here. We're good. Chat? We're good. We're good. It goes in. Okay. Perfect. Perfect. That's actually a pretty clean thread. I think one of these, I saw some debris. I ran these through the ultrasonic cleaner, but I think I saw one that just had a little bit of schmutz in it. So we'll use some oil on those. And now I need to figure out if I have any M6, did I say? Set screws. Okay, I have 5 6x6s. I have 7 6x8s. And, actually a bunch of 6x10s. And I have 6x12s, but not 8. Oh, I do have enough. So I'm just going to use the 6x12s. Why not use literally the largest set screws here? Because I have a decent amount of distance to cover. So I haven't tried these set screws out, but I think this is going to ride up. Honestly, that's not too far. Let me, I'm going to try and measure that. Let me get my caliper. Okay. When I say in theory, if you want to know, Desu, the in theory is that I went to town making these, and I put 3/8 fine thread in the first batch. So, yeah. I grabbed like a 3/8 bottoming tap, And then I saw the plug tab, and I'm like, well, a plug tab's better for this because it's through hole. And I grabbed the plug tab, and I didn't check the fucking thread pitch. So all of my metric stuff, I don't have fine versus coarse. I've just always done coarse metric stuff. But I have both fine and coarse of Imperial. And since I'm used to metric, I'm used to working with that. So yeah, I made the first batch of these. They're not finished, obviously. Which have the wrong fucking thread in them. It's the same size, but one's a fine thread. So, which sucks, because the fine thread actually looks really nice. Tell me that's not a beautiful looking thread, chat. Yeah, and these haven't gone through the ultrasonic cleaner, so they're extra dirty. Okay. But yeah, that's why. That was like an hour lost, but luckily these are basically free, the blanks. So, I'm gonna go down here at the end of the table, where I'm gonna probably have to raise you up one more time here, chat. Bear with me. We're going up. Oh, we already went up there. Shit. Okay. I want to remove the camera, but I actually don't have a great place to set the camera down. So we're gonna do a sketchy raising you up again, chat, okay? Here we go. Just don't worry. Not that sketchy. One leg at a time. Don't drop the camera. Okay. It's very hard raising a 40-pound tripod, 50-pound tripod all alone. Especially when you're trying not to break your camera. Okay. Please be high enough. It is not level, but I can fix that in post. Okay. How are we doing, chat? We looking good? Okay, now the monitor is so high up there. Alright, let's come in here. Okay. Fuck yeah. And yeah, I think we can go to that larger focus area, chat? Thoughts? We'll go to... Let's go to wide. We'll see how well this focus mode works. If it doesn't work, say, hey, the focus mode isn't great. And then I'll read that in about a half hour. Okay, let me loosen this so I can balance the camera. Or, not balance, but get it leveled. Okay. Okay, camera should be level. You ready, chat? Did you just say bear with me? Do you still have the Elise? Yes, I do. It's not running, hasn't been running for a while, but I'd love to get that up and running again. Okay, is this stable? Yeah, I think so. One of the legs is like a little bit longer than the others. I think it's fine, chat, okay? Don't bump this. Okay, so I've got the T-nut in here, and I just want to measure basically how high up this lifts out of the bottom, basically how long I need those set screws to be. I think we're totally fine with even just like a couple millimeters, but I just want to see how high this nut rides in the T-slot. So right now I'm getting 9.03 millimeters. Chat, can you remember that? 9.03 millimeters. Okay. And then when it's raised up and pushing all the way up in the slot, it is 5.26. So 903 minus 5.26, we've got like 3.7 millimeters, which is actually way less of a gap than I thought. which is good. But we'll just use the we'll use the 6x12 set screws, which is massively overkill, but it'll be good for thread engagement. So, because we're going to be reefing on these bad boys. To be honest, we'll just strip the heads before we do any other damage, so. Okay, let's see what size Allen these are. They are, I bet they're a 2.5, or are they a 3 mil? 3. Okay, that's good, because I'll take every bit I can get there, so I don't end up stripping these out. So yeah, we're gonna put some screws in my nuts. Okay, just gotta run these set screws in there, and this is what we're gonna do. So tell me about your day, chat. Beautiful. That's pretty good. They're still deep in those holes, but I'm not too worried about it. Yeah, 377. Damn, I was actually pretty close on my math there. Okay, so yeah, this is first set screw in here. Looking pretty good. That's kind of like flush, roughly, with the bottom. And then we've got good thread engagement up top, which is great. And they're recessed plenty. They will get a little dirty. These are stainless screws, which is just happen to be what I have for. Actually, most fasteners I have are stainless. I like using stainless fasteners. I haven't had galling issues before, but I know galling issues are a thing. But I don't know. I've always kind of just been a fan of using stainless steel. Kind of for everything. I really like 17.4 now. That's probably my favorite material is 17.4. Really easy to heat treat. So you have like kind of roughly the corrosion resistance of a 304 stainless, which 304 is probably like kind of the most common stainless you run into. Maybe like a 301 for like large stuff. But stainless is pretty soft stuff. Compared to normal steels, it's actually not a fantastic material from a strength perspective. Obviously, it's better than aluminum, but it's quite a bit worse than steel. But 17.4 stainless is susceptible to a little bit more corrosion, because that's kind of like how it is. It seems like pretty much all materials that we're able to make more corrosion resistant kind of naturally get weaker. Just kind of probably the RNG of how the universe works. But 17.4 stainless actually has a higher tensile strength than most steels, and it can be hardened quite well. It does have cracking issues, though, so it's important to heat treat it correctly. Sometimes you do like 2 passes of heat treat, but it's just really cool stuff. So that's what I kind of make all my tools in the shop out of, because you have that like strength of a actual steel. You have the corrosion resistance, at least in a shop environment, of stainless, right? Like, yeah, out in the world, 17.4 that's hardened isn't going to be completely corrosion resistant, but in a shop environment like this that's pretty clean, not super rainy or wet, or it's never rainy in here, 17.4 is kind of amazing. It's like, you can harden it so you can have a good bearing surface, you can use it for a precision gauge, and you don't have like major wear issues due to it just being too soft like aluminum does, or even stainless. Like normal 304 or 316 stainless, I would say is actually quite soft, and thus for like a bearing surface on like a precision tool that you want to keep its same tolerance over time, yeah, you kind of get fucked with a normal stainless, because it's just a little too soft on its own. So, first thing I need to do is I need to move my milling machine over for maximum travel, because these cuts are very, 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 very long cuts. I am assuming that we are going to do these cuts. We may not, depending on if we can get these clamps to work, but I'm basically running the table all the way over, which is really weird. Normally you don't work this far out on a mill, but I'm trying to do these parts in 2 parts, and then I'm gonna basically do all the drilling, all of the tapping in one quick go on all of these. Let me go out a bit here, I guess. I don't know. The macro lens is definitely interesting for this. I think for some shops it's really nice, for some it kind of sucks. So I've got the T-nuts I made with their set screws in, and what I'm hoping to do is I should be able to slap in my face mill that we'll be using. I'm actually going to rotate the inserts out or around. I've got round inserts in there wherever it is. Hello, face mill. Face mill, there it is. So, right now I've got round inserts in here. Adjusting the camera, 1 second. Doing this solo is tough, chat. Okay, so I've got these round inserts in here right now. They're good, but the last cut that I made on the aluminum, and why some of these spots are kind of scratched on this aluminum, is because I tried to shave down a little bit of the mount that I had, and unfortunately the mounts that I had were quite hard. Ended up chipping one of these carbide things, and that cut some gross grooves into this aluminum. Obviously, they're actually not that bad, but it pisses me off, right? So these are like not deep at all. These are probably, just feeling it out, probably 20, 30 micron deep. But I really want to see how good of a finish I can get on this aluminum. This is already, I would say, a pretty good finish. You can see here, this like pattern where you can kind of see a reversal of the tool, whether it's cutting on the front or on the back, kind of shows you where there's like very, very minor deviations in the cutting path of my milling machine, which is actually kind of cool to see. So my plan here is to basically figure out, I want to put the part as far as I possibly can into the travel in the machine. So we're at kind of the maximum travel right now. I'm getting my cutter lined up so I know how, like, where I'll make contact. I literally have to be like right up against it. And so this is roughly where I'm going to place this bar. So let me make a quick mark. This mark goes away fast because the machine's really oily. So hopefully it will last for a little bit. So I'll make a mark here. And that is basically where we want to position the right side of this so we can basically reposition on the Y here. You're going to see, if we make this cut, you're going to see that we're really pushing the limits here. I should have done this in 3 pieces. But once again, it's not a precision part, so all I really want is one smooth cut at this point. So I think this bar, I can actually kind of have, I could potentially have all 4 clamps, but then it's kind of less supported at the sides. Not 100% sure how I want to do this yet. So since we have to do the whole face, you can't have clamps on top, right? So if I had a clamp clamping right on top, that'd be really easy and I wouldn't have any problems. But I can't do that here. So I need to figure out where this needs to be locked in. So we'll move our bar roughly in place. This isn't necessarily exactly where we're going to commit, but it's where we're going to do kind of a first test. So they recommend doing a 90-degree turn, apparently. So I want it probably right about there would be good. So now I get to see if I can lock down this nut, which is the whole point of making these nuts, chat. The whole point. So, unfortunately, you can't really see this. Not really used to being this far down the table. Very weird. Okay, I'm going to try and hold it in place while I snug up these set screws, and the set screws will hopefully push this T-nut up into the slot, which is then going to make it rigid. Which, okay, the T-nut's got, or the set screws grabbed. I need to figure out, I actually want to torque these, because I really don't want to ruin these. So, okay. Hold it magnetically. Aluminum reacts with electric currents, right? Kind of? Because you can induce an electric current through it, but I don't think that's useful in any way. Right? You can't really get like a magnetism-like effect from that, can you? You can get it like sticky and to resist by like generating a current through it, or however that shit works. Okay, what was I grabbing, chat? Torque wrench. Torque wrench, and you said 3 millimeter hex. Chat, what are the torque specs of a stainless steel bolt into steel with M6 thread? You're too slow. I'm going to look it up myself. Weirdly, this is something that, like, Claude is actually pretty good at sometimes. Sometimes it just makes it up. Stainless steel bolts into steel M6 thread, lubricated torque spec. Okay, we'll let Claude cook that one away while we don't think. And then, perfect. What's it saying? 6 or 7 Newton meters? 6 or 7 Newton meters? Is that reasonable, chat? I don't know what that is. 6 or 7 Newton meters. I'm gonna do, that's 6.2. 6.5. We'll do 6.5. What's that, chat? Yeah, we're gonna go 6.5 Newton meters, and then, where's a good oil? Okay. We'll, come on. There we go. Just putting some oil in those holes. This is just a light oil. Really nothing special. Okay, I put a lot of oil in those. Okay, those should soak in a bit. Lubricated threads require less torque, because there's less friction, obviously. So, can I not get deep enough with this torque wrench? Maybe. Maybe. No. No, I cannot. Can I? Shit. Shit. That's cringe. Whoops. I'm panicking, chat. I'm panicking. I actually I've got some alternatives. I'll be right back. There, chat. Okay, come on. Oh, these aren't really that much longer. Wait. I think we're good, chat. you telling me that the 3 mil is the one I already have out right now? Yes, it is. Okay. Machinist form says 9 meters? Yeah. Okay, so I think this is a 3 mil. Oh, that's good. Okay. Okay, so I just have to get, I think, the a 1/4 inch socket, or a 1/4 inch hex is what standard things are. Perfect. We're cooking, chat. Okay. Hold on to your poggers. We're going in. 6.5. Yep. Sending it. Get in there. There it is. Hello? Hello? Okay, thank fuck. Okay, yeah, good on that. Nice! Nice! Okay, so that's in there. Nice! So, I don't know how much clamping force that is, but I think it's actually like a decent amount. So, I always forget the formula for that. Technically depends on wet versus dry threads and all sorts of stuff. So the question is, now when I put this in there, is this theoretically going to stay in place? And yeah, that feels really good. Yeah, I think that's a really good design. I'm happy with that. Fuck yeah. So you can't see that in there. And I don't think there's a really good angle because I can't put you to the side of the mill right now due to the way the shop's set up. So I can either try and do 2 on each side or 1 on each side. Not 100% sure what I want to do. They're quite small, but we're also going to be doing pretty light cuts. So let me make sure this bar is clean. This is the raw stock side. I don't know if you've seen kind of bar stock aluminum. Really basic stuff. I think it's extruded. Yeah, it's definitely extruded. Pretty much everything is extruded. So I could do that. It's a tough call, chat. So let me dismount you for a second. Okay? Because I can do this. We can go on trips together. That's the whole point of this setup, chat. So if I'm ever not giving you a good shot, remember you can say, hey, you can take your wireless camera on a wireless adventure. Okay. So, here's kind of the nut. So you should be able to see that that T-nut in there. Let's go manual focus now. So you can see that T-nut in there with the set screws. Honestly, with the lighting, you're kind of getting fucked. I don't know if that comes out at all for you, chat. But that T-nut is wedged up in there. I don't have a light, chat. I don't have a light. So, effectively, the predicament here that's kind of tricky is, do I want to have the bar straddle this rail, but due to that, I'm kind of overhanging on the sides, and I would get 2 clamps on each side, because I could put a clamp on each of the T-slots, or I can go for 1 clamp, but centered. And I think 2 clamps is better for this case. Just because we are going to be taking cuts. Okay, how does this go in here again? Do I have to pull this back? Yes. Yes? No? Yes? Hello? Help. There we go. Nope. Help. This camera mount's too fidgety, chat. There we go. Okay. Whew. Alright, let me catch up on Twitch chat. We're on autofocus, right? Yeah, okay. Twitch chat, you're in my pocket. What did I miss? Okay, just Destiny talking about Torque. Alright, easy. That's an easy ignore, chat. That's what we call that, easy ignore. So, then what I want to do is I want to get another one lined up. So, I didn't really think about this, but I don't really know how hard it's going to be to get these to line up close enough to each other. Yeah, no idea. So, we'll see if we have to, like, get something to kind of transfer the position better. Maybe we can do that quick. But I'm gonna just try and eyeball it, chat, okay? Actually, I can just grab a square. I'll line it up by eyeball, but we'll use a square. Okay. Definitely have some parallax here, but I don't think it matters that much, chat. But these don't have a huge amount of play in how much rotation you get with this canning action, so I'm kind of being careful with, I want to be careful with not having too much travel on these, because they don't have a very long clamping range. Okay. Perfect. Okay. So, oh yeah. That's pretty nifty. Those look pretty damn good, in my opinion. Okay? So, shout-outs to Eyeballs. Who's Eyeballs? I've never seen that streamer. I do need to get a washer to put under these, I think. Yeah. We'll see. Not 100% sure how I'm going to position these yet. Or how much say I even have in positioning them. I don't know what size they are. I'm going to guess they look like an 1/8 inch hex. I was way off. Way bigger than 1/8 inch. 5:30 seconds. Wow, 3/8? I would not have thought that those are 3/8 inch. I was way off. Okay? 3/8. Dang. Okay, so you're supposed to tighten them down, and then you're supposed to back them off one rotation, and then that's where you're supposed to decide your clampage from. Kind of in an awkward spot here now. So, now that these are clamped in, I can move the table to a reasonable position. Okay. These, same thing, tight, loosen, so these are one turn loose. So in theory now, I can line up the hexes. I actually want to now position these so that the can is going to push these into the part, which is it's actually kind of hard to see the offset in this. Right here. Okay. So, I might better shot here in a minute. Okay, I might have to... Yeah, I think the back one, I'm going to have to move a little bit closer, I think. Yep. Yep. Yeah, this is max distance. Okay, that's fine. Not a big deal. Not a big deal, chat. We just have to loosen those and go back into position. Let's see how tight these feel. Pretty tight. I don't like that some metal came out of that hole. That makes me feel like I have stripped that, but that wouldn't really make sense. We were quite careful, I would say, with those torque specs. But maybe I made a mistake there? I don't think so. I think they're fine. Okay, we're moving. So this is kind of the downside of this setup here, is positioning these just sucks. So I didn't really think about that with the design. Come on. This one grabbing? Yeah. And then I'll read chat after I position this one. So if you have your questions, comments, or concerns, bring them up now. Sick. Yeah, unfortunately, I can't quite hit the, Okay, they actually stay in place better than I thought. Nice. Okay. I gotta keep that there. I want to get that clamped in place without moving it. Oh, I won't be able to reach it, will I? Come on, get in there. Nope. Shit. Okay. I think it's actually in position. I don't think it's moving around that much. I don't know. I haven't really gotten a feel for this, or if I'm gonna hate using these clamps. Okay. Am I over tightening those? If I am, that's fine. I'll just make new ones at some point. Okay. And I missed, because it repositioned when I clamped it. Okay, so this is a tough problem. These fucking things are going to move around. It's going to be really hard to line up the these T-slots on Forge. So, let me try and get you in here, chat. I don't really know how I want to tackle this. Okay. Is that working? Not working, chat? Really don't want this power cable in my feet. Really don't want this power cable in my feet. There we go. Okay, so really the problem is that these have a very small amount of travel that they can do with their camming action, and thus I have to be quite precise where I put the holes. So here it will be like that. Actually, I think we're good. Maybe. Yeah! That should be fine. Because this one can move the bar. Okay. And this one can move the bar. Perfect. So they're not perfectly straight yet. So I have to go a little closer on this one. Son of a bitch. Son of a bitch. Okay. I don't know how far I've gone so far. I think just a little bit. Okay. I think I moved it like a couple millimeters. We'll see. But yeah, I didn't really think this one through of how hard it'd be to line up multiple of these. At least in this position. Okay, so that's tight. Back it off one turn. And now that looks good. So that I can back out a bit. This one also I can back out a bit. I think those are pretty damn good. I don't know exactly where parallel is, but okay, I'm happy with that. Hell yeah. Hell yeah. So, chat, are you going to remind me? Are you going to remind me that this one is not tightened yet? It kind of is. It's not going to move, but it's not fully tight yet, okay? So, remind me that. Chat, are you going to remind me that? No. Okay. Damn. Okay, I just looked at my computer. The stream quality is fucking mint when I actually move the camera into a good spot. But damn, that looks really nice. Okay. So, I might raise these up on washers. I'm not 100% sure. I'm just getting the T-nuts in the right positions so far. Technically, there's actually, they've got good, like, CAD drawings of where exactly you're supposed to, put the holes. So, in theory, I could do that. So, let's see. Let's try and get this focused. There we go. We'll focus you there where I'm working. Perfect. Okay, remind me I'm not on autofocus. So, let's just try to get these lined up. Okay, we got this one, rotate it away, get it up there. I think that's where that would sit, right? Lower it down a bit. Yeah. That's clamping, pushing it away. Oh, that's kind of cool. If I just hold it up, I get kind of like a piston movement on that T-nut, so it's like really obvious to see where that travel is. Which I kind of like that. And then let's see if I can hit this one here. Can't get it all the way down. Okay. So I think... yeah, I wonder if there's any... I really need to make a screw that's like just exactly the right diameter so I can line these up, but yeah, where did I have these? Let me just eyeball it. That looks basically exactly centered over those outside holes, so that's just what I'm going to do then. That should be pretty easy. I think I can actually eyeball these up quite good then. But yeah, I could also put like a marking on these to show me like where the edge of the part should sit for them to work or something like that. Okay. This one, I think I'm a little off on that one. Gotta get it first up. I don't know, these are definitely a little finicky. Obviously, if you're doing a lot of parts, it'd be good. But we'll do it right there. I imagine I can line that up by eye pretty damn close, pretty consistently. Okay, loosen loosen this one. This one has to go a little bit in, I think. Yep. That's probably too far. Perfect. Okay. So, hopefully... Bam, bam. These are all snug now. That's snug. And that's snug. Okay. Okay. Let me check where these ones are. Yeah, I think that's good. Please. Please work. So these ones are going to be trickier because I have the other side constraining this system. Okay, all the way down. One rotation back. We're actually going to go all the way to this part here. Is it going to fit? No. No. We're off by quite a bit, actually. Damn it, chat. That looks good. Definitely could make a jig or a line or something to make this process better. No, I'm way too far. God damn it, chat. Okay. I was able to sneak in there. Oh, come on. Oh, let's go. Shh. Come on. Oh, let's move it with the thing. With the nut in. Get over there, you bitch. Okay, get it firm up on there. Good. Hold. Sneak. Oh, I can't get in there. Son of a bitch. I can... Oh no, it's a disaster, chat. It's a fucking disaster. Honestly, probably should just caliper it at this point. Okay. Try not to move the T-nut. Calipers would have probably been faster at this point. Okay. Up on there. Okay. Here we go. Isn't this riveting, chat? Just kidding, we're screwing, not riveting. Ha! Woo! Got him. Fucking got him. Okay. Yep. Oh, chat, I am getting excited to use these nuts. Oh, this is looking cool. Okay. And back that one off. Max dist. We barely fit in here. Yeah! Let's fucking go. Okay. Now we're fucking cooking. All right, let's try a caliper for this next one. See if that one works. It's not riveting, it's nuts. Okay. This is kind of awkward. Kind of like really awkward. The caliper here. I could go all the way. I'll just go all the way from the end of the table. Let me get a bigger caliper. Fucking wrecked them. Okay. Boop. 189.89. 189.89. Okay, and I should be able to just loosen this. Yep. Loosen that one. And then push it with the caliper. There's actually a chip right on this corner of my milling machine. So, it's actually really hard to line that up. 189.89. That's probably good. That's close. Okay. Up. Snug. And snug. Okay. This is it, chat. This is the big one. If this fits, we might be able to actually machine if everything works. Woo! We're in. We're in. We are fucking in, chat. Let's go. Okay, so now we have to loosen these all back and then tighten them. Woo! Holy. This is really cool. Okay, I am stoked for this cut. I have never been able to do a cut like this before. Okay, so this bar has to come like straight up now. These are all in here but not rigid, and then I'm actually, due to seeing that metal, which I don't know if was due to those threads stripping or if it was the head of the bolt or something, I'm not 100% sure, but I'm worried enough about it that I'm going to back off. We're going to go to 5 Newton meters. So, I don't know what that was. I don't know if that was actually coming out of there or if that was from a previous cut or something. But I'm just going to go a little bit down on the torque here. So, let's go to, we'll do 5.1. 5.1. So, a little soft. A little softer than I want. Okay, where is the driver for this? There it is. Alright. So, we'll loosen off the ones that we've potentially over-tightened. I don't think we've gone that over-tight, but yeah, like that feels fine. I don't know. It's probably fine. But we'll switch to 5. Yeah, it's very, very gentle now. Okay. 5. 5. Oh, I'm so excited to use these. But yeah. Hopefully we have enough force on these to keep them in place. But they're snugging up, which is good. Yep. Okay, now I have some threaded slots at the right positions. Alright, so let's throw these in here. So now those are all torqued in. Now we're going to position these nuts. Figure out where they go. That's tight. Back it off a full turn. Same for these. Rinse and repeat. But yeah. This is going to be really interesting due to how low profile these are. I mean, the part might go flying across the room. But hopefully it doesn't. So, this really would make a lot of operations more viable in the shop, especially if I don't need to as precisely line these up. So, it's really because these are small clamps. So if I use the neck size up, you get like double the amount of camming travel, which is just more tolerance for setup error, which is quite nice. Okay, that's tight. Back off. Tight. Back move them all back to their maximum travel distance, which is there, and go there. Let's make sure we have enough travel here. We do, so we'll go there for this one. Okay, so this bar hopefully will fit in here. Okay, it wasn't straight. There we go. Okay, let's line this up. And then, we're gonna see if these tighten. Are they gonna tighten, chat? Let's get you a new shot here. Oh, and you're not plugged in, chat. Wait, you are plugged. Nope. You aren't. Okay. That's not good. That's not good, chat. Okay, you're plugged in. You're plugged in. Okay. So now we're gonna go and try and tighten these up. So let's go to autofocus. Hopefully it will work here, and then I'll just go to like a somewhat point focus. Let's go center fix. There we go. That should be a good focus positioning. Okay, so in theory now, I just need to get this bar roughly parallel with the table. I'm just going to do it by caliper. This doesn't have to be perfect. Let's just say, let's go a little further. Let's go 45 from the edge. So 45. And same thing over here. 44. Okay, I don't know how much this is going to move around when we clamp this down, but now we get to start tightening these cam screws, which is going to cause this bar to push into the other side. I have no idea if this is going to work well or not. So far it looks good. Let me make sure everything's tapped down here, just in case it's not sitting, but it looks like it's sitting okay. But yeah, it might scoop up a bit as I tighten it. Sounds okay. A little hollow in the center, but these are tightening. Not seeing any movement in the areas I don't want movement, so we're going to actually go pretty tight on these. So yeah, all of them positively snugged up, which is really good. None of them are slipping. Yeah. Okay, so this is clamped in here. Pretty good. So let's see how square I am now that I've lined it up. I'm probably not perfectly parallel, probably good enough. 45-10, and this one's gonna be a little closer, I think. 45-20. That's fucking good. Okay, so this is bang on, chat. And then I'm curious if I put a bow in this, and I did. I put a big bow in there. Wow. Wow! It's not that much, I don't think. Yeah, I don't know if the bar is already a little bent. Man, is that really that much force on this? That's quite incredible. Let's see. I think that is just the bar. I mean, that's still in there, kind of tight. Man, these things are fucking crazy. That one's at max travel. Yeah, I don't know what I do for this. I came down a little bit. I guess just don't go as tight, question mark? Obviously I could do other work holding, but... Man, I kind of wasn't expecting it to get that tight. Okay, that looks good. We can keep going a little bit more, maybe? That looks good. Okay, I'm happy with that. It'll probably bend a little bit as we machine, or it'll machine a little bit of a bend in it, but at least we'll get a consistent surface finish. It's a really small radius, so I'm not too worried about it. So next we have to, gonna just rotate these carbide inserts, just because one of them was chipped. So we're just gonna make sure we have clean edges on all these inserts. You'll see that some of these are a little chipped up. Not too bad. Definitely usable. But I want to get kind of the best surface finish I can. And, man, I don't know if I remember what cutting parameters I was using, but whatever I was using was giving me a really good cut. So, hopefully I can repro that. Shit, I should have taken notes. When I was having really good cuts, I was like, I should write down exactly my parameters, because they turned out really good, but then I didn't. So I'm going to have to do a couple passes to find good parameters here. So I'm just rotating these, loosening them enough so I can rotate them, getting them into a new spot, and tighten them down. So, I think only one of them's kind of chipped, but I'm just kind of going by eyeball here. You can kind of see when there's a small chip on them. I'm not going to be able to hold this in focus, I don't think, while I do it. But just kind of nudging them around here. Aluminum likes really sharp edges. Aluminum's pretty soft, so you kind of need to cut it. You can't really push it out of the way, so you really need to get a clean cut right off the rip to get the best finish in aluminum. I am no expert at aluminum. Why is this one so tight? Because I'm going the wrong way. Why am I going the wrong way, chat? Okay, this insert's pretty chipped, but there's a clean spot on it. It's the beautiful thing about round inserts. You can just kind of rotate them until you get a clean edge. Okay. It's in there good. And this one's also maybe slightly chipped. Man, I don't remember what parameters I used, chat. Okay. I'm happy with that. I am happy with that. Okay, you should have nice new cutting faces. I'm just going to consult the feeds and speeds, because I probably used them when I did this. Okay. Did you tighten the... Yeah, I've tightened all of them, chat. Okay, this says 1,000 to 5,000 surface feet per minute. I'm not going to be able to go that high. That's 3,000 average times 0.3048 is meters a minute. It's millimeters a minute. Pi 325.4. It's a 3-inch cutter. Pi D tool 3,800 RPM. Let let me double check that. Just making sure, because that's fucking high. Pi 25.4 times 3. Yep, 3819 RPM and a feed of 0.003 to 0.018. So we're gonna go. Let's do 0.005. 25.4. 0.127 per tooth. We have 5 teeth. We have that RPM. Whoa. Oh, I did math wrong, I think. Whoa. 0.003? 25.4? What am I doing wrong here? Uh, 1400. Okay, I see. Yeah, so I can't run my machine that fast. We'll probably go to like 500, which is a third of this. 2.91. So 1300 RPM and 500 millimeters a minute? Is that what we want? 1300 RPM. 5 teeth. 0.003. That's 0.07 millimeters times that. That's 500. Okay, 1312 is what we're going to be doing for the speed today, chats. And let me see how much material we have to remove. It's really not much. This needs to be 25 millimeters. And we have 2543 here. Okay, so we've got a decent amount to go, but the other side isn't cleaned up, so we want to remove as little as we possibly can here. So let's try. I still have that mount there, so let me remove that mount quick. Come on. Okay. So, now we can move the knee up a bit more. Okay, lock the knee in place. And next, our cutting parameters, we're going to go 0.1 deep is my plan here. Hopefully I don't have too much of a bow in this. I'm a little worried. I hope I didn't over-torque those and put too much of a bow in it. Let me see. I think it's fine. Oh yeah, that's not bad at all. I think that is just the other side. Yeah, I'm not seeing really any curve on the actual flat surface. So, I think we're good, chat. Maybe. Bottom right is not tightened. This one? No, that's tight. They're all tightened. Okay, we're going to go coordinate system 1, absolute. We're going to set this as our 0 for Z. We're then going to go down. So we're going to lock the quill in place at 0. And that's going to be our cut. Now I'm going to figure out roughly where my first cut's going to be, or where the 0 is going to be on the cutter. We'll say this is. Then we're going to do 10, we're going to do 10 millimeters per pass. So we're going for a really, really light cut. And then let me get my speed kind of calibrated. Yeah, that's 500. Okay. We're fucking ready, chat. We're ready. So, gotta go all the way over to make sure we got the machine oiled. Okay. That's maximum travel. Okay, I'll move that. And then I'll get you in frame, don't worry, chat. So we're gonna do a 10 millimeter deep cut here. So, and by deep I mean the width of the cut. And then we're gonna go 0.1 millimeters deep. Or thereabouts. This is gonna be a 0.09 millimeter deep cut, according to my DRO. So, let's get you in here. The macro is actually really good for the cut part. First of all, I can go manual focus and make sure that you are in focus the entire cut. And the camera's actually like quite far away, which is really nice. A normal camera would be quite up in my business. Okay, we're going 1312 is going to be our cut. Putting some WD-40 down. 1312. 1312 RPM. It actually seems to be like a good resonant frequency. And then in theory, this is the cut. Okay? So, hopefully this is right. Sending it. Hello? You got nothing? We not contacting? No, not quite. Okay. Right. Is this due to the bow? Because, let's see. I can actually kind of measure the bow with this. Well, fortunately, I like working on that side of the machine where the camera is. That's negative 0.09. Negative 0.01. Uh-oh. Is there a big bow? Positive 6. Okay. Let's see if we can just come down a little bit on these. Let's just pull them back a bit. Yeah, I mean, those are like quite light now. Okay, this is reading 0.04. Negative 0.04, which is like okay-ish. Negative 12? Fuck! Really? Are these generating that much force? I might have underestimated these guys. Yeah, they're definitely clamping. Okay. Alright, let's just go. Let's go long T handle type. Well, you can't see it. Okay. Went a lot less tight now. Now we're at negative 19. Okay. Oh. I just don't want that much of a bow. Positive 5.05. .08. Okay, so there's a little bit, but it's just what we're gonna get. I'm gonna just cinch on a little bit more. I'm more worried about the part flying off than being perfect. If we put a little bow in it, not the end of the world. Once again, we're going to be cutting this into a bunch of individual parts, so it doesn't matter too much if we're perfect here. Man, that really does bow. Damn. I can't believe that. Like, you can really feel that. That's crazy. So, negative 0.26. Slight cinch on that. Slight cinch on that. Negative 0.24. Negative 0.21. Negative 0.18. Okay. I'm happy with that. It's going to be a really, really minor curve. Okay. And we'll see what it is at the end. I can't believe that, chat. Oh, perfect. We're good. We're bang on, chat. We're bang on. Yeah, literally like within probably 2,000, probably 50 micron. So I'm happy with this now. Now we can lock this down at 0. Negative 0.02 is fine. Then we'll raise up the knee. We'll go up to our 0.1 cut. I'll actually do like a 0.13. Okay, so this one will actually cut. Thoughts? 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 Here we go. There we go. Super light cut. Nothing crazy. Oh, we're looking good, chat. We're looking good. Let's see the best place to put Twitch chat. Is this a good spot? Oh, she buttery. She buttery. And I think I just turned on my muting on my headphones, so if I talk weird, that's why. But, yeah. Pretty consistent cut all the way through. So I'm happy with this. And then we're going to do a shit ton of passes. So we're only going to do 10 millimeters per pass. Obviously, we could do this whole thing in one go. But I've been doing a lot of work on this machine to try and really get it to perform well with multiple passes, trying to get like really good consistency on the table movement. And really, I want to try that out. And to try that out, I really want to see if I get ridges when I take many, many cuts like this. So we didn't fully clean up there. And, okay. Good to know. Okay, so, we've got a decent amount of chatter in the center there. And we didn't quite touch this side, which makes sense. This is the lowest part of the bar. But that chatter in the center will not go away unless we clamp this in a different way. So, yeah, we have to clamp this differently. Son of a bitch! Yeah. So I'll try and get you in here in a second once I get this in the center to show you kind of what that chatter looks like. It comes up on camera, but it's just some light roughness in the surface here, which is just due to the fact that that isn't actually sitting flush on the ground there, or flush on the machine. Where are we? Where are we, chat? Is that it? Is that the cut? Yeah, you see those, like, scallopy marks? That's just some chatter from the bar flexing when that cutter's going through it, because it's being clamped and it's being pushed on from the sides here, and this part is so long. Honestly, chat, I think the correct fix for this is to just cut this bar in half and not have such a long bar, at least when I'm clamping it like this. Because I think that's going to be the best way to go about this, is just cut this bar in half, get rid of a lot of that lever action, because it's kind of an awkward size to hold it from the side. Well, I do have some adjustable parallels, which I could use to kind of make arbitrarily spacing to hold it from the side. So, alright. Let's clean it off. Get rid of some of the confetti. Yeah. I guess I should have expected that. But I was hoping this cut was going to be light enough, but I don't know. We kind of were talking about this whole time. We were very concerned about that, so we probably should have just known. Okay, the other option would be I probably could throw a clamp on like one side or the other, depending on what side I'm taking a cut on, but it still would vary a little bit from cut to cut. So that looks pretty good there. I think we still have plenty of material, and once again, it's not a precision part. It's a fucking mount. Okay? But it is practice too. 25. Yeah, I'd say absolute worst case scenario here. That looks like a 25-40. Now this is the bowed area, so in theory, right at the end will be the lowest. Yeah, like 25-26. So we're good. I want to hit 25 millimeters. Once again, doesn't matter, not a precision part. But I really want to get a nice surface finish on it. Just kind of practicing with these clamps. So let's see. But yeah, I think that makes sense. None of that is too surprising to me. And we're just going for trying to get a really nice, really clean cut here. And we just need to rethink our clamping. So, what I'll probably have to do is, so this last rail, the last flat spot of my milling machine is the worst one by quite a bit. That's not a focus. Okay. So this one is like raised up just a little bit higher than the other, so I really don't like having the part on that back one. So I think what I'm going to do is I'm going to have the part over the center two, and then we'll clamp it from the sides, which is just way better. Unfortunately, it's not leveraging my cool nuts, but now we get to undo all that setup that we did. How does that feel? Okay, loosen that. But yeah, I imagine if you set up a fixture plate, because you're like turning out parts, it would be really cool to like have these exactly where you need them, because sliding parts in here is really fucking easy. As long as you loosen them all. But yeah, that's really sweet. I like that quite a bit. So far, I'm going to rate these clamps a 9 out of 10. Okay? Got the table clean, and now we have to remove these. And now the next ones are easier and harder to set up. They're easier in that positioning doesn't matter nearly as much, because we're going to be coming from the sides. But harder in that we're going to have to use a we're gonna have to use some like adjustable parallels to pick up the slack. Because these clamps aren't going to be able to reach the bar from where we're about to put them. So, okay, let's loosen the set screws that we worked hard on. Yeah, that 5 Newton meters feels pretty good. That feels like where I'd probably put it hand tight. Okay, so now we're moving these nuts to the back. So now we're going to have a nut in the front and the back. I think I have to loosen this one. Some of my T-slots have some weird bite marks in them, which apparently just kind of happens over time. Yeah, this one's being pretty fussy here. So I don't know exactly where that tightness is. I don't know if it's the walls getting close, but sometimes I just need to kind of bang it in there a bit more. There you go. So there's just a couple tight spots in the machine. Okay. There we go. So now these are going to be quite far. We want to clamp them, I don't know where. I guess math would say like equal distance from the ends and the center, right? Because you're making, you want the shortest path between support or some shit? I don't know. It's what I would think. Oh. It's not because it's raised up. It's just tight on the walls. Yeah, these are fresh peanuts, and yeah, my table is just not. Unfortunately, it's tight for normal peanuts. Okay, so let's make sure everything's clean. Don't want to get anything under the part we're going to clamp down. Make sure the part itself is clean, especially after doing cuts. And we'll set it down. Okay, so this part has to go about here-ish, which means I think, yeah, clamping. You like my jamming the T-slot down? Oh, I hate that. Okay, so these are quite far from where we need to be. Yeah, I'll have to machine those T-nuts slightly to the side. Okay, so I've got them right there and there. I could maybe go in a little bit, just a smidge, not too much, but I think we're not going to over-adjust these, because I don't think it matters too much here, but we'll see. Yeah, I don't know the best place to support them. Let me check in on Jack. Can you grip the bar sideways? Oh, yeah, that's what we're doing. Yeah. So, we'll still lock these in place, even though it doesn't really matter as much anymore. We'll make sure they're somewhat aligned with each other, and they are, just really by eyeball here. So, these ones, I'm not even going to torque them. I'm just going to kind of roughly feel them out. That looks good. That's good. That's good. Okay, so really the problem is now we have a pretty big gap, so these front ones I'll be able to get nice and flush. right? But the ones in the back, I'm going to need to take up that slack with something that I can pretty precisely change the depth of, which I think I'm going to use my adjustable parallels here. So, okay, rotate it one back, find kind of where that camming is. Okay, seems like about there. Same thing here. But yeah, I actually should have clamped them from the side like this in the first place. I don't know, I just thought it'd be less work. But honestly, positioning those is like more work, I would argue, than just doing this. So, okay. And then those will be actually already quite parallel. Put the bar right about there. So how are we doing on our distances here from eyeball? I think we're a little off, but it's probably not that big of a deal. It's like 150 mil. The centers are 284, and then to the end again is like a 138. It's like a centimeter off perfect center, but they're actually pretty equally spaced in terms of distance from the point to the nearest support, which I imagine is what you want to optimize. And that looks pretty good. Maybe bump it just a bit down. Not that it matters. Okay, so that looks good. Okay, making sure there's nothing under it. And now, let's see how big of a gap I gotta fill. Which, I don't have a great way of getting you behind the mill, sorry. Bam. And max travel is here. Okay. It's a decent gap, but I can use like a 1, 2, 3 block. I can use adjustable parallels. I can use non-adjustable parallels. There's kind of a bunch of different things I could use here to kind of wedge. But yeah, this is going to be way better than the initial setup. So, okay. Okay, perfect. So this is now going to tell me the distance that I need to cover. $51.29. $51.24. So that's really good. And then I subtract off the width of the head. What did I say? 51.29 minus 20.63. 51.29 minus 20.63. 30.66. So a little more than an inch. 30.66. 30.66. Let's see what we got. Got 25.45 with this brass. I have 25.30, 28.66. Oh, that's probably pretty close. 28.63, 28.72. Okay. Those are pretty good. These T-nuts are like almost the right length. How much movement do I have on this? I think think I have a decent amount, right? On the cam. What does it say? Let me go to their website. Okay, where's their normal? There we go. These are the 3/8 version, which has a .05. Am I reading that right? .05 is the camming action. .05. 0.05. So 1.2 mil. So we gotta get within 1.2 mil of that. What did I say? 30 something? 30.66. So what could I find that would be 30? Because 28.64 is fucking close, but it's like a slightly off. I feel like adjustable parallels cannot withstand high clamping pressure. Yeah, I don't want to use adjustable parallels here. So I'm trying to find just like some random thing that is the right size. Or that can stack. I could just maybe use, it's kind of random if these clamps are long enough. Oh, I think they're too tall. Yeah, those are too tall. I can't use those. I guess I can use the, oh, come on. It's gotta be something. 2266 plus, oh, what was that, 1580? Not quite. Got these. 2535. 2850. Oh, come on. I just need a random thing. Am I not being creative enough? Ooh, 3174. No. 2865. I could also stack things, but stacking things while clamping is not very fun. IMO. IMO. I have some aluminum stock. Okay, this is 350. 350. 350. Yeah. Wait, what's this? 3848. Shit. It's weird. I just don't have much like square bar. Just measuring random things. Just measuring random things. Ooh, 3205. 3170? Nope, too big. Fuck! What do we do, chat? What do we do? Do I keep randomly measuring things until we get something with the right size? Or do I come up with an alternative but actually plausible strategy? Which I don't know what shim. Yeah, I probably can just cut something down to that size. It should be pretty easy to hit that on just a quick saw. What's this? Okay, a little piece of loomy. Little piece of loom. Okay, yeah, we're just gonna cut a piece of loom down. Okay. So, I'm going to use this fairly thick piece of aluminum flat stock. Not infinitely thick, but thick enough, I think, to transfer the force. It's 38, so it's too long, but we need 30.66. So I think we're just going to shoot for 30. So I'm just going to stripe this out quick. Put a quick line in it, and hopefully we can hit this on the saw. At least close enough. Can I get some thoughts and prayers, chat? Okay. Here we go! Drum roll. Drum roll, please, chat. Drum roll. Brrrr. Brrrr. There's a burr. There's a burr. Hold. Keep drumming. Keep drumming. Oh, okay. We fucking nailed it. 29.97. 29.97. There you go. There you go. There you go. And yep, that slides in. And I think that's gonna probably be enough because I have travel on both. So I actually have like 3mm of travel. So we gotta make one more of them. But yeah, that was pretty pog. I kind of forgot that using a miter saw on aluminum, you can get like actually really clean cuts. I'm used to bandsaw when I'm working with metal is using a bandsaw. But bandsaws are not very accurate, and they leave a pretty shit edge. But a miter saw, I can line up that tooth real fucking clean. There we go. Okay. Okay. I'm just gonna deburr these. Just so they don't sit on the table in a weird way. Not really for any other reason. We'll see how this one came out too. Come on, get out of there, you fucking burr. Okay, whatever. Drum roll. Ugh. Yeah, 30.02. Probably depends if there's a burr on it where I'm measuring. Yeah, 29.99. Fuck yeah. Okay. Turns out I can miter quite accurate. Feels fucking good, man. Boop, 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 and boop. What's great is I'll be able to clamp the other bar with this exact same setup, even though it's a slightly different length, because we're clamping from the sides. So, see? See, chat? So hopefully these don't rise up too much or something, but they're gonna be what we're gonna try, okay? Okay? So, let's see. Okay, it doesn't quite get tight, which means that we're gonna have to use some of the travel on the front one, which is fine. So we'll turn that to like half. Okay, we're getting bite. This is good, this is good, this is good. So that's like half engaged. Same thing here, we'll go to like half engagements. And this one, coming around. Okay, we're getting tight, chat. So now, we can, yeah, that was actually really not too bad. Just whipping out those clamps. So, still feels a little hollow in the center. I don't know how much bend there is in this. Tighten that. Tighten that. Tighten this. Tighten that. Okay, that is fucking clamped. Okay. Now, I'm gonna go touch off this corner that we know is the lowest, and then we're gonna try and basically cut no material off this, right? So, we already used some material. Luckily, we have margins, but we don't want to use too much more. This is gonna be my Y0. We're gonna come back, slide over. We're going all the way to the far end. Maybe we'll just do the first cut in that direction, because it doesn't really matter. But yeah, we're going to see how low that gets. Because we know this should be the lowest corner. So I'll zero my Z. And it will come down on this. Definitely sounds a little hollow. I think in theory, I actually want to do more clamps. I could, in theory, use the bigger clamps and do more of them. Let's see what happens. We'll see what happens. If we don't like it, we'll do more clamps or use the bigger clamps, because for this force, I can actually use the big clamps and just use normal T-nuts. They don't have to be the locking T-nuts. Okay, so did we zero this? I'm pretty sure I did. That's probably what I did, but let's double check. Yep, she's zeroed. Okay, go all the way over. Bam. And we'll go to zero on this. I know I'm blocking the camera. Okay, we'll zero that, and then we're gonna go like point. That's like 28 micron. So this is like very light cut. Very light cut. So let's see. Here we go. Fucking send it. It's clean. It's cleaned up. It's clean. It's clean, chat. Oh, it's beautiful. Oh, that's a nice cut. I'm gonna go up in speed. Oh, I'm not touching now. Okay. Actually, I really like the finish I was getting there. Maybe I'll leave it where I was at. What was that? 1300? Let me double check. But we gotta cut down a little bit further now that it's not going up. But, now we're cutting again. Beautiful. Beautiful. That's looking nice. Okay, what's my favorite here? Let's try a little faster. Go like that. I think I like 1,500 the most here for this cut. Okay, so it's not perfectly cleaned up. Beautiful. Beautiful. Alright, let's go another... This is going to be like 0.08 total. Put some W on it. But yeah, this cut is very light. That last cut might have been too light that we just got some rubbing. Honestly, I'm going to go a little deeper here because we have, in theory, we can afford it. This is now like 0.1. Okay, let's double check. That's locked. Send it. This is now the new 0, and hopefully this is the final cut. I really hope this will work for everything. It's touching, it's beautiful. That looks really good. Oh, it's looking good, chat. It's looking real good. Oh, ho, ho, ho. You're not going to be able to see it until we probably do like the next 1 or 2 cuts and you have the right angle on it, but it looks fucking mint. Oh my god, chat. Oh my. And we cleaned up that old... Yep, the old gross part is cleaned up. There it is, chat. We fucking did it. That's a pog champ. Fuck yeah. Okay. I'm just gonna let it run into the limit switch. I have it set up to be right for this cut, for these cuts. Bam. And we'll clean the tool. Okay. I am happy with that. So, let's get you in, chat. Come on. Come on, chat. Who's a good boy? Who's a good boy, chat? Who's a good chat? Who's a good chat? Who's a good chat? Are you a good chat? Yeah. Are you a good chat? Yeah. Oh, who's a good chat? Who's a good chat? Fucking losers. Okay, let's come in here. Is that it? Is that the bar? That is. How's it looking? How's it looking, chat? Wait, am I looking at the right thing? Let's see. Gotta get you the right angle with the light so you can appreciate it. How does it look? How's it looking? You want a more top-down view? How's it look? How's it look? How do you rate it? How do you rate it? Yeah, like, where's my head? My head's like here. There you go. That's POV. How's it looking, chat? How's it looking? I can't see. I can't see. Is that look good? Did I do a good job, chat? Okay, I'm gonna go read chat. Why am I having fun doing this? How macro can we go? That's max macro. Yup. I don't know why that was fun, chat. Okay. How's she looking? What about looking like down it? Is that artistic or something? I don't know. It looks really good to me, chat, okay? I don't know why it looks bad on camera. No, it looks great. Okay. You're going back in your saddle, chat. Back in your saddle. Okay. Did you like that position of the camera, chat, for the cut? Otherwise, I could maybe change it up a bit. Okay, we're gonna go another 10 millimeters. Okay, here we go. But yeah, these clamps are working great. Honestly, the string looks fucking good. Not to toot my own boot. Not to toot my own boot, but the stream looks pretty fucking good. I still can't believe I spent like 6 hours reverse engineering only for it to be a fucking firewall being blocked. I can't believe that. I just have never had to really deal with firewalling unless I'm running a fucking server. Oh, beautiful, chat. Okay. This is exhibiting exactly what I expect, where I'm seeing very slight fluctuations in the milling table changing this pattern in the center. This is really cool. Okay. We're going to do another 10 millimeters, which, keep in mind, these cuts are ridiculously light. Like, obviously I could face this whole thing in, like, 1 or 2 passes. But I really want to see how this is performing in terms of, like, step. So these cuts are starting to get bigger, because we didn't cut some of this bar. So since this is a slightly deeper cut, since we already did those first passes, with the different parameters, hopefully we don't fuck ourselves too much here, because having a different cut, obviously I'd expect some changes in how that cutter is engaging with the material, but I'm happy with this. So, here at back are covering the specific LCD model from the pictures. It's quite an old one. It is quite an old one. It's the one that I used in high school, actually. My 4-monitor setup that I had in high school, that I spent my hard-earned money to get. Which, honestly, was pretty sick. FreeBSD, 4 monitors. You're really pushing X to its limits. I had 2 NVIDIA 460 GPUs pushing those 4 monitors because you could only do 2 monitors per, or at least on Linux you could only do 2. I think it is just 2 per back then. Okay, 10 more. Here we go. Boop. So if I really wanted the most perfect consistent, I'd probably only approach from one direction. Oh my god, Chad, it's looking good. She's looking great. Is there a way to roughly gauge the surface roughness? I do not have a profileometer. I think that's what does surface roughness, is a profileometer. Never been something I've been too crazy into. I would say the surface roughness is quite not rough. If there's any variation from cutting the strips, it's not visible in stream yet. It is the key, really the big key, was trimming my mill, not trimming it to its table, but instead trimming it to the actual plane of motion, which is different. My table is a wedge, right? And thus trimming directly to the table, which is what you normally are supposed to do, just wasn't quite good. And it was really fucking annoying, because I would just always get steps. But yeah, this is incredible. This is definitely probably the best finish I've gotten in aluminum, especially in like a big long part like this. Obviously the smaller a part, the easier it is to get a consistent finish, because you're just in one spot the whole fucking time. But with this, I'm kind of using that full travel of the machine. But she's looking real good. You're supposed to adjust the table to the movement? You can't do that. That's not an option. I can't change a solid piece of cast iron. Maybe some machines you can do that, but not Bridgeport milling machines or Bridgeport clones. There is no such adjustment. But it's also a light duty machine, so I don't know. Maybe I don't really know how you do an adjustable table parallelism. You would have to scrape in the table. So it is looking real fucking good. How's it looking on the screen, chat? Because I am fucking thrilled with how this is turning out right now. Looks perfect, yeah. Yeah, scraper grind. Yeah. My plan is to just grind this table. This mill, like, this back, the back flat of this mill, right across that, the furthest one, the furthest flat part of the table is about, like, 1/1000th of an inch, so like 25 or 30 micron. Either high or low, I can't remember. But yeah, basically when you sweep an indicator, you see that each of these like individual lanes is at quite different elevation. Now, that's probably just normal for a Bridgeport, right? You're not supposed to be doing shit below 1,000 on a Bridgeport anyway, so it doesn't fucking matter. But that drives me nuts. I don't like it. So I will be at least probably grinding the table of this, if my grinding setup works. In fact, I might actually try and grind this table before I grind my lathe, because it's got way more meat I could just keep grinding it down or send it off somewhere or buy a new table if I absolutely had to do that. So, but yeah, this is looking pretty damn good, chat. That's looking very good. Very good. So, yep, just a very, very light pattern on there, which is really just from the speed, because I'm actually taking this cut quite slow. But yeah, looking pretty mirror finish. Yeah, it's very good. Oh, it's just beautiful, chat. You love to see it. That's actually pretty good cutting parameters here. I feel like I'm getting a decent-sized chip. They're a little wispy, of course. But I'm pretty happy with that. But yeah, I've never seen my machine cut this nice. So that's good. I mean, it's super trimmed. I think the way that we have this clamped in is way better than the first time, obviously. Should have just done that the first time. That's kind of how it is. I feel like machining, especially when you're kind of doing like random setups like this, I imagine when you're actually making parts, it's probably way easier because you just make jigs that you kind of have forever. But when you're kind of doing one-off parts, you're really like kind of just coming up with random work holding that will like work for your part. And oftentimes, the first thing you try was just a little too lazy. So, how do you clean the mess afterwards? Yep, just vacuum it up. I use the vacuum a lot. My vacuum, obviously, the like plastic in the vacuum is covered in metal. So actually the last time I was cutting these bars and faced them off, I scratched it when I vacuumed it off. Just because my vacuum probably has some pieces of stainless steel and steel embedded into the plastic on the nozzle. So I'm actually trying to be really careful here to only blow. Makes kind of more of a mess. But I mean, I have to vacuum fucking everything anyways. So at least I'm gonna blow things off the part, and then I can vacuum around them. But yeah, I don't wanna. Obviously, once again, doesn't matter. It's not a precision part. It's a fucking mount, but it looks nice. I think a lot of people really swear by sweeping. So this very last cut put a very, very, very fine ridge in here. And the only reason that we have a fine ridge in there now that we didn't have before is because that side of the bar was actually not machined at all. That was the first time it was touched. So that was quite a deep cut compared to the rest of the cuts we've done. And thus that slightly just tips the tool a little bit more into the part. So that kind of sucks, but I'm not going to take another pass. So I'm pretty happy with this finish. Normally I would try to continue all the way out on the part. Yeah, maybe I am getting a little bit of a step there, but this is where you would expect to see kind of the max step. So this will be the last pass on this side here. My cat wants me to go to sleep. Good night? Yeah, good night. Good night. Yeah, just a little step there. Really not much. I mean, at this point, if I wanted this to come out as flat as possible, I think I'd want to continue doing these cuts, because I think it's cutting, let's see, is that true? Because, yeah, I think it's going to keep pushing that all the way off the edge. Yeah, I mean, in theory, I should just, like, fly cut this. Now that I know that I'm getting really good performance out of this. But I don't really have a great fly cutter for this size. Okay. So, let's see how she looks, chat. How's she looking? Yeah, that's really good. Yep, just got some ridges, which is just what you would get anytime you take multiple passes on something. But they're very, very light ridges. And they vary based on where it is in the part, which shows me that that is either just differences in where the mill is in height when it's traveling. But yeah, if we wanted the best, most consistent finish on here, we'd want to do a fly cut, so we're doing it all in one cut. But I really did want to see how this performed with kind of doing those steps. So I'm happy with that. I rate that 8 out of 8. Okay, so let's pull this off. This was, which size were those? 3/16, I think, was the size of these clamps. Okay, is that loose enough to pull out? Yes. Nice! Nice. So here's what we got, chat. How'd we do? How'd we do? I wasn't holding it. So you can see where we had kind of the full contact here on the final passes, and then you see the ridges that are starting to slowly come in as we're making those multiple passes, but they are unbelievably shallow. I mean, I would say from feel, probably 10 micron deep, which is really probably like literally tool deflection differences in like very local high and low spots. You know, milling is just not a very precise operation, unfortunately. So pretty happy with that. I'm going to give that a clean, then we'll flip it over to the other side, and then we'll try and finish the other side, and that's probably going to be it. Really just wanted to try out these clamps, try out the camera, but up next we'll be actually making holes in these. Yeah, this is going to be a pain in the ass to clean. Okay. Set down our bar. Okay. Move our little shimmies. Okay. Okay. And wipe it down. That's pretty good. Sorry, I'm blocking the camera. Just cleaning. Literally just cleaning. Okay. So, while it's out of the machine, we can throw a caliper on it quick. Just see if we are fucked for hitting our tolerance. Because we have definitely taken more off than I anticipated from this side, just from those extra passes. We're at 25... 25-15. $25.04 in the center. So the center, 25.08 on the side. So basically, we're just gonna take as little of cut as we possibly can until this cleans up, and that is gonna be our final dimension on that. Okay. In we go. Make sure that's roughly lined up with our Sharpie mark. And we can do these cuts quite a bit faster, chat. Okay? I know you guys were like, I didn't like how slow your cut was. Aluminum likes speed, okay? And since aluminum likes speed, we're gonna give it fucking speed. Okay? Does that sound fun? So, I was running my machine not quite at its move max. Really, I'm limited, in aluminum, I'm limited by the speed my table can traverse, right? And that was, we just did 500 millimeters a minute, but we're just gonna basically run this on rapids and run at the full, 1,000. And then we're also going to do 20 millimeter wide cuts. Actually, we could probably go... I like staying to a third of the cutter. Yeah, we'll do... we can do 25 millimeter wide. So... we'll do that. How's that sound, chat? So we're going to... Okay, what's great is we can reuse the positioning. So the first one, we'll do this at 25. 25. So next, in theory, we're probably already really close to where we actually want to be for height, but just in case we have any height changes, I do like double checking it. Let's get some contact on here. Yep. Yeah, that end is kind of lifting up a bit. Yeah, I definitely want more mounts. I think that's really going to be the weak point here. Is, yeah, the bar is a little bit up on this end here. Okay. I'll zero this. Okay. I'm going to call that 0. Call that 0. We'll go down. And we'll go over. Okay, chat. Here we go. So we're going a little faster. Let's see where this settles in. And then we're going to do, let's see if we can do a 0.05 to clean up. I don't quite think it will clean up, but we'll see. Yeah, we're going quite a bit faster. Speed it up even more. Yep, we're not cleaning up, so we gotta go deeper. Okay, let's go 0.15 .12. We're going to need to go deeper with that. Let's go .16. Here we go. We'll see if this cleans up. I'll re-zero this. Re-zero this. I really hope this cleans up. Oh, I also go faster here. And that's not fully cleaned up here. But I'm going to finish the cut and see where we end up. And there we go. So we got a low spot in the center. It's totally fine. Not too worried about it. Go more. We'll go 0.1 more. Because that's a pretty low spot. Come on! This is definitely the low spot, and I think we're cleaned up. Yeah, we got it. We got it, Check. We got it. We got it. We got it. So yeah, we probably took like 0.2 off, so we're going to be a little low in some of the spots, but not too bad. Okay, and we're going to advance 25 here. Here we go! That looks good. Yeah, this is 3,500 RPM and about 1,000 millimeters a minute. So that's basically maxing out my power speed. Yep, and some not great patterns at the end there, but it's fine. Hell yeah. So the ridge is kind of only high on the ends. It's not that high. It's a little higher than the first cuts. The first side that we did, obviously. You can kind of hear that. You can hear that hollowness. And that's just because we don't have any mounts on that side. And we just should. Like, I think if we really, really cared, we should have mounts, like, all the way at the end. Those ends are just unsupported and kind of flapping around in the air. So, alright, let's cut. Yep, totally fine. Alright, so this side is a little more aggressive, but it turned out quite good. Not as good as the other side, but like, I'm happy with that. There's some chatter on this side. This spot is just not fully bitten into with a clamp. Well, we'll take it off and take a look at it. looks good. That looks good. Let me, I don't have any rags. Uh-oh. Uh-oh. Gotta go grab a new one. Yeah. Okay. So, got it nice and clean. But yeah, it's definitely not as good on this side. But, let's see. Just cleaning it. I'm just cleaning it, Chad. Don't worry, I'm not doing anything to it. It's fine, Chad. It's fine. It's fine. It's not perfect. It's fine. Okay. So we've got the first side here. Side A. Side A. Pretty good. I'd say really good. And then side B. This is the second side we did. This one's a little rougher, but still actually quite... Okay, you lost autofocus privileges, camera. I'll go right about here. Okay, so little worse on the surface finish here, but it's pretty good. I'd say like that's one of kind of the worst areas there. Yeah, that is the worst area over there. But it's really completely fine. So, here you go. Here you go. We'll see. I don't know. I'll probably fly cut these because I want them to be perfect. But anyways, that's all I got for you today. Just wanted to kind of try out the camera, try out the clamps. That was pretty good. Zero on my table. But yeah, I'm going to clean up and that's going to be my night. So cheers, thanks for stopping by. I don't have a way of ending the stream without going inside. I'm going to go do that now. Alright, chat. Cheers!